Okay, it's time for questions and answers on Unit 6. And I'm going to start out with a homework problem, actually two homework problems, but they have the same setup. It's a person or a child that's on a swing, and we need to know the gravitational potential energy of the child on the swing. And this is a bit of a geometry problem because to get the gravitational potential energy, we need to know the height above the ground, but the problem tells you the angle. So given this angle, how can we figure out what the height is above the ground? So let's set this up, do some geometry, and we can figure this out. Notice that the swing has a length that I'll call r. So this distance is r if the swing were hanging straight down to the ground, and this distance is r as well when the swing swings up to some angle. So let's draw the base of this right triangle. And now you can see that the height h is down here. Let me redraw this triangle without the kid on the swing. So this whole thing is r. This side is r. And this part of the right triangle is the adjacent side of the triangle. So it's r cosine theta. Now the height is this little leftover bit, which means that it's the full length of the swing r minus that side of the right triangle, r cosine theta. So we can say that h is r minus r cos theta. So this full distance minus that distance in the triangle, that gives you this leftover bit h, which is the child's height above the ground. That's what you use for the gravitational potential energy. You can write this a little more compactly if you want. Factor out the r. One minus cosine theta. And by the way, you can see that this expression makes sense for some extreme values. For instance, if theta is 0 degrees, that would mean that the child is at the bottom of the swing, they're at ground level. Cosine of 0 is 1. 1 minus 1 is 0, so the height is 0. The child's at ground level. Another extreme value would be if theta were 90 degrees and the child were at kind of it would make the swing perpendicular or the rope parallel to the ground. So theta equals 90. That would mean cosine 90 is 0, and you get h equals r. The child is not as high off the ground as you can get on a swing.